Hello? Hello, hello. Okay. Mr. Consistent out here. Does that work? There we go. Mr. Consistent. We're doing it every day. Or trying to at least. Otherwise I won't study. Um, yeah, so today's physics. It feels so, like I said this yesterday, but like, it feels so weird doing this. Like, I feel like I was way more into it last time, like last year. Now it's just, yeah. But oh well, no. We get done, we get done. Okay, physics. As I said yesterday, I did slides for all my subjects, but um, I only did real in-depth ones for English and SOR. This is not that in-depth. I've only done it for like a few topics, you'll see. Okay, okay. Yeah, this is like a Chrome extension that I forgot I had on my laptop, so it'll be handy. Um, Advanced mechanics. We'll just go through the slide presentation. Suvat. That's easy to remember right there. Everyone should know this by now. Suvat equations are on the formula sheet as well. If I can get it out. Uh, there, there, there. There you go. And oh wow, straight into it. Jeez. This is the monkey problem, and we know that the bullet, like this hunter guy right here, is shooting at the monkey, who is 8 meters horizontally and 5 meters vertically away, and he's shooting at it, and the bullet's traveling at 50 meters per second. So the question's asking if the monkey will get shot. So, geez. So you want to find theta, obviously, which you use tan, the inverse of tan, with the 5 meters and the 8 meters. Yeah, theta equals 32. Then you need to find the time that takes the bullet to travel. So you do 50 cos theta to find this in meters per second, the horizontal velocity, which gets you 42 meters per second. Then you know velocity equals distance over time, which is 8 meters. 8 meters is the distance. So 42 equals 8 over time. Then you use that to find the time that it takes the bullet to go from here to the monkey. And you want to figure out if the monkey falls fast enough that it will miss the bullet, like the bullet will go above it. So that's what this calculation is. So it'll drop 17 centimeters, which is not a lot. And just in case you find the displacement of the bullet, how high it is, because maybe it's a bit less, maybe it drops. It's not exactly, it's never going to be an exact straight line. So you use sine theta. You know the velocity. Use suvat. That's annoying there. Then that's how far the bullet drops, and that's how far the monkey drops. So just say from here to here is 17 centimeters, and the bullet goes 18 centimeters down. So because it's such a small difference, less than a centimeter difference, the monkey will get hit. And yeah, jeez. Oh, gotta get back in the zone. Next page. Circular motion. That's all on the formula sheet. What the heck is this? What am I doing here? Oh, wait. The tension is equal to gravity. Remember this. So, whatever. I got that wrong in my first task and it kind of stuffed me up. I knew it and I crossed it out, but oh well. That's an annotation. So this is saying if there's a ball here or something, an object, and it's being spun around, it goes around like that. Jeez. I was so tempted not to do physics study there. Ugh. Kepler's first law is that orbits are elliptical. His second law is the T formula, if I can get it up. This one, down here. His third one. No, oh wait. No, wait, what? Hold on. Hold the phone. That's the T formula. That's the T. That's not the T formula. Whatever the formula that I just said. What's this one? Equal areas at the same time. Doesn't that kind of it's fine. Just remember elliptical, equal areas, and that formula. Velocity. Oh, escape velocity. That's easy to derive. You just make kinetic energy equal the potential energy. So you want kinetic plus potential to equal 0. And then that's the escape. Satellite speed, energy. Yeah, because that relates back to the escape velocity because you want the total energy to equal 0. And I need to click off that. Bank turns, that's how you derive it. Tan theta, so theta's here, but also theta is here. I think, because if that's perpendicular to that, I think that's theta as well. Oh wait, no, that's theta up here. Oh yeah, yeah, I can see that. So theta's up here, if you can see my cursor. Theta's up here, as seen by that. So tan theta equals FC on mg, like pretend mg is coming down this way. Then FC, we know FC equals mv squared on r. So tan theta equals mv squared on rmg, the m's cross off. Rg tan theta equals v squared. V equals square root of that. That's what this is. And that's how you find the optimal velocity on a bank turn using that. Nature of light. What the heck? Oh, these are the experiments. Okay. Alright. Oh, I have a highlight. Okay, so the important ones. Shit. The important ones, Fazoo, Fazout, Foucault, and that's it. But we just do these two. Oh, I'm getting distracted, holy shit. Yeah. Don't really need to do any other one. You can see they get close to the known value of 3 times 10 to the 8. I mean, they're a bit off, but like, you know, not much. Okay, Faraday. We're now doing electromagnet. This is probably the hardest one. An EMF, Faraday's law is that an EMF is induced whenever a circuit experiences a change of magnetic flux, and the EMF induced in a circuit is directly proportional to the rate of change of the magnetic flux through the circuit. I'm writing yep. Then lens came along, waddled along, and he's like, the direction of the induced electric current by a changing magnetic field is in the opposite direction because it wants to oppose the change that was initially made by the magnetic field. Ugh, jeez, it's too early for this shit. So there's some diagrams. What's this? Is this a link? Oh, it's just a. No. Alright, so the magnet's going in. This is a shit color, but you know. The magnet's going in to the wire. The field is coming out of the north. So when it goes in, you use right hand rule. You know that the magnetic field is going. Wait, did I edit this photo? I don't think I did this right. I edited them. Is that his right hand or left hand? No, that's his right hand. Oh my gosh. North to south. Boom. Boom. No, wait. What do the... Saying... The fuck? Why can't I do it? It's going out. Okay. I'm losing my brain. I'm just gonna put those there. Ah, here we go. You're never gonna get a question like this. Like, I'm looking at the top left. I'm looking at this photo. I think if this hand is wrapped around this part of the wire, so it's saying if his hand is wrapped around here, the magnetic field is going through, but then the current would be going down. I think these hands are wrong, but that's what the next slide's for. So if you have a wire and you have a wire, boom, that's the magnetic field. So fingers going into the page, wrapping around, the current will go that way. And if it's dots, it will go the other way because it's coming out. You think of it like the arrowhead. Here you go. Oh, wait, why did I look at this one? Oh, so the current is wrapping around, therefore the North Pole. Thumb points to north. Okay, if thumb points to north, wait, so it should be like this. Thumb points to north, hence this is wrong then. That's definitely wrong. Jeez. Hey, this one's easy. Field. I wouldn't use the finger, I'd just say palm. Current enforces with the palm. Oh yeah, like this one. Right here. What the heck is this? I think this is just the view coming from here. No, no, it's not. That, wait, what? This current is going around like that. Okay. Oh, this is from this side. This is from this side. Okay. Never mind. I'm just done. Eddy currents. Is this the last thing? This is the last thing. Okay, so you have a magnetic plate, or whatever, between two poles of a magnet. As the plate moves into the magnetic field, eddy currents induce a magnetic field to repel the magnet. As the plate moves out of the magnetic field, the eddy currents induce a magnetic field to attract the magnet back. Late note, yeah, but it's true. Yeah. Okay. So if the plate's moving this way, as seen by the arrows, as the plate moves into it to repel. So it's attracting, this is induced to repel it. As it's leaving, it wants to attract back. Jeez, late night, yeah, for sure. No, I didn't put anything for that one. Okay, let's get started then. Alright, color. Okay. Oh, this is easy. Is it? Is it easy? Wait. I need the formula. Here you go. VP over VS equals NP over NS, right? So VP over VS equals NP over NS. Okay, so now question 1. This is the 2022 paper. So VP is 20. Wait, no. NP is 20. My bad. Let me write this whole thing out. VP over VS equals NP over NS equals 20 turns. And we're trying to find the number of turns on the second. So 20 over NS equals 100. That's the input voltage over 400. So 1,4 equals 20 over NS. Therefore, NS equals 80. Because times 20 by 4 and times NS onto the other side. That's just basic algebra. So you should get C for that one, but that's like the easiest question. And it's gonna just get harder from there. Great. Can I delete? Can I, hello? Whoa, whoa, whoa. Um, alright. Let's just reload the website. Jeez, that was weird. What feature of the star is likely to be directly responsible for these absorption lines? Size? No. Color? No. Distance from Earth? No. It's there. Because that's what's inside. You match it up with known spectras, and that's what you get. A radio isotope emits radiation which is deflected by an electric field as shown. What type of radiation is this? Well, I'm just going to go hazard a guess here that it's either positron or electron. Just because it's affected by the electric field? The electron, because it's going towards positive. Don't look at the answers, guys. C, D, D. Yep, electron, chemical, 80. Yep, so we're 100% right so far. A current carrying wire is in a magnetic field as shown. What is the direction of the force on the wire? Okay, so you want to go, shit, points to north, right? So the thumb goes down, it should be coming out of the page, but shit. Let's go back to here. Thumb points to north, doesn't it? What? What? Thumb points to north. Oh wait, yeah, into the beige. What was I doing before? My fingers point wait, are your fingers the current? No, because if your fingers are the current and no, if my fingers are the current, then the force is coming out. I mean, if my fingers are the field, but it says my fingers are the field. My thumb's the field. It's going down. Fingers are the field. It's going out. The fuck? Jeez. Okay. And you'll work on the right hand wall. Oh, neutron. Oh, that's easy. Just even those, make them equal 0. So you need 2 of these. So up, down, down. B. The next one's A, guys. The next one's A. Oh, well, that's easy because it's closer to the gravitational. Like, imagine you're doing. Alright, imagine you're swinging a pendulum, right? It's going. Zhup. If you can see my cursor, it's going. Whoop, whoop. The fast kinetic energy is the how fast it is or whatever, like the movement. So when is the pendulum the fastest? At the bottom. If you're doing, if you know, if you've ever been on one of those rides where you're on this, like in a carnival, and it goes like all the way around, like, or it builds up. Whenever it gets to here, it's like really slow, like it's nearly stops, and you feel like you're gonna fall back down. But then I don't know. It's it's A. It's not nuclear. It's not total. Total would be the same. Potential is at Q. A photon has an energy of 9 times 10 to the minus 24 joules. What is the frequency? What the shit is that? Yuck. I don't know what that is. I'm throwing that out. Okay. So I think this is E equals HF. E equals 9 times 10 to the 24 minus 24. 9 times 10 to the minus 24 over H. H is H over 6.626 times 10 to the minus 34. So that should cross off, and that should be 10 to the minus 10 in the denominator. I think. I think I'm allowed to do that. Then we just chuck it into our calculators. 9 times 10. No, wait, it's just 9. Divided by 6.626 times 10 to the minus 10. It should be C. I hope. Yes. Let's go. An object is launched with an initial velocity u and hits a wall with a final velocity v. The vertical component of v is less than the vertical component of u. the vertical component of V is greater than the vertical component of U. The horizontal, well, we know it's not C or D because the horizontal is the same throughout. So it has to be A because you can see U's vertical component. Should I draw it up? Sure. U's vertical component there. V is very small. The radiation emitted. Holy fuck! It's only been 30 minutes. Huh. Shit. Radiation by black body has a peak wavelength of that. What is its temperature? So this is where you go in. No. This is where you go in here. Waves in thermodynamics. Is it here? I don't know. Here you go. So you want wavelength max equals B over T. Well, we know the wavelength. Yeah, but we gotta know. Why is my mouse acting up? What's B? Where's B? There it is. So T equals, I'm just rearranging the equation, times 10 to the minus 3 over wavelength max, which is 5.8 times 10 to the minus 7. So be careful. If that was in nanometers, you would have to change the units. Times 10 to the minus 3. You want to divide that by 5.8 times 10 to the minus 3. Oh, minus 7, I mean. 4.99. What the heck? Oh, never mind. I see what I did wrong. 2.898 times 10 to the minus 3. You know, it's always good when you can see where you've gone wrong in your problem. So that gives me 4996 Kelvin, which is closest to 5000. So it should be C. What question was this? 9. Did I get 8 right at least? Oh, yeah. Well, C. The next one's not D. The orbital velocity v of a satellite around a planet is given by v equals square root gm on r. Which graph is consistent with this relationship? Okay, so you just rearrange it. So v squared equals gm on r. Then you make gm, pretend it's what's it called? Like if you have y equals 2x, you make it the coefficient. You make gm the coefficient, if that makes sense. So v squared equals gm outside of 1 on r. And there's your relationship. V squared, 1 on r. The displacement of the projectile as a function of time is shown. Which velocity time graph corresponds to this motion? Okay, so this is just the derivative. So it's getting less and less steep. Yeah, it's just a decrease. and it hits 0 at that stationary point, and it comes back up. No. Hold the phone. It's either B or C. Because it's not A, it's not D, it doesn't increase. Can the velocity... I'm gonna go with B. Yes, it is B. Because it is the derivative. It's just the derivative. If... Yeah. So, wait, let me draw this up. So, if that corresponds to that, that's a shit arrow. This one, C, would be... The displacement would be this. It'll be a cubic. Where it has a horizontal point of inflection. Wait, inner math is coming out right now, jeez. Moves in the region at a constant velocity. What is the direction of the particle's velocity? To the left, to the right, up, or down the page? Alright, so the field is going down. It wants to move down due to the electric field. The magnetic field, I don't think, has... Well, if the magnetic field's going into the page... What was I going to say? Down? Nope. Okay. To the right. Why is that? Why is it not taken into account? So if it's going into the page... Okay. Question 12 and question 2, was it? Was it question 2? Question 12 and question 4. Go remember those. One satellite has twice the mass of the other. Which quantity would be different for the two satellites? Well, we can go have a centripetal acceleration. Whoops. Is v squared on r. So it can't be that because they have the same velocity. Well, I mean, that's a good process of elimination. If it v squared on r, they both have to have the same velocity. If they have different velocities, that means they have different speeds. So it can't be D or A by that logic. Momentum. I might just go with momentum. Yep. Because momentum is mv squared or something. What change does experiment will produce the results shown by line Y? Increasing the frequency of radiation, using a metal that has a greater work function, decreasing the intensity of the incident radiation, decreasing the maximum energy of the work function. I have no idea. That's 14. Right now we're on a good track. We only got 3 wrong. If I were to guess, I'd guess C. Always go for C. It was B. 2 was this one you just use the equation. Just use the equation. This one, I think. This one right here. So if I get it, F on L equals, let's just name the U naught and 2 pi P. Don't do this in the exam, write it out. I1, I2 over R. So then you go here, separated by a distance D. Oh, alright, so the length's the same, so you wanna, that equals that, then if you wanna times it, the length, no, the separation is increased to 4D, so instead of D being in the denominator for R is the radius in the equation, which is the same as D, you change that to 4D, and the current in each wire is doubled, so I1 becomes 2I1, and I2 becomes 2I2. And that all crosses off, so it doesn't change. So it should be A. It's A. Oh, we've done this. IY never equals IX. I think that's false. I haven't even read the question, but I'm just looking at the diagram. Because the polarization is the exact same. IY never equals IZ. IY sometimes equals IZ. IY sometimes equals I naught. Wait, did I not see that this equals... Oh, I know, this one equals A. Whew. Yeah, I was like trimming myself out. It's not A. I would say it's either B or C, but in what case could it sometimes equal? Because I don't know. If this is 0, if the unpolarized light is 0, then Y would be 0, and Z would be 0. I'd say sometimes. I'd say C. Yes. For that reason only. Oh, so we did this for an assessment. or not, one kid in my class did this for an assessment, and we're meant to make summary sheets so that we can all get it. And I don't know if we're getting, I don't think we're going to get it. Or unless we have got it and I'm just dumb. Which is a fair point, but it's not looking likely. Due to gravity, electric field. I would say straight up it's B. B, 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 B. D. Alright, that's fine. Question 18. Add to the list. Generator converts kinetic to electrical. Wouldn't you say? I'll just say C again. A. A. Okay. 19 as well. What are we on? We're on 15 out of 20. Wouldn't it just be B? Cha-ching. Because it's like further away. Can't be the same. Can't be equal. Can't be equal again. Yeah. Alright. Cha-ching, man. How many blank pages do you want? Oh, shit. Oh, no. Might take a break. I think that would be the best option. Maybe like 5-10 minutes. And then we'll be back at it. Alright. Alright. Oof. Back at it. Going hard. Alright. I'm running out of paper. The positions of two stars, X and Y, are shown in this HR diagram. Compare qualitatively the surface temperature and luminosity of X and Y. Think Y is hotter, and luminosity, I think Y is more luminous as well. Come on. Did I click on it? No. Temperature, Kelvin. That's so weird. Why does it decrease that? And luminosity. Okay. Yeah, I kind of thought that. So we'd get 1 mark. So temperature increases. Only boring astronauts find something, something, something. I don't know. Obaf Gakum. Obaf Gakum. I don't know how you're meant to remember this. But it goes hotter to the left, colder to the right. Luminosity increases going up and down. Identify the elements undergoing fusion in the core of each star X and Y. Okay, I think X is the proton-proton. So hydrogen, helium, or I'll just say hydrogen. And Y is the heavier elements. Oh. Oh, okay, so I would get 1 mark. Hydrogen, heavy. This is helium, CNO cycle. Okay. Oh, alright. Oh, far out. I might just do a few more questions and write down what I get up to. And we can do a different subject because it is boring me out. Well, two features. Obviously, the more turns in the second wire, that means a greater voltage. If you do the thing, VP, VS over VS equals NP over NS. So if it's 3 over 6, that means there's a greater voltage in the second wire. and also that it's laminated. It prevents it from overheating. Is that it? Yep. Oh wait, is it not to efficiency? I mean, I don't know. Maybe it's. Huh. Who knows? That could be used to determine a value for the speed of light in your answer. Identify one factor that would limit the accuracy. So I would talk about the rotating mirror. So here I would draw a diagram as well. Source of light shines onto mirror, boom, another mirror, boom, mirror rotates, boom. And you know the speed of the mirror, so then the rotational speed, so you know how, because you know the angle that's turned from when you observe the light, you'll know how far it's turned, and then you can work out how long it's taken the light to travel, and that's the speed of light to cover that distance, and you know the distance. Boom, boom. Oh, you can literally be that simple? Oh, then what? Yeah, hell yeah. I would have said that. I was going to say that, but they're like, no, can't be. Why is the decay constant the same as wavelength? Oh, jeez. So 80, you want to go to 40, find the half-life, 16 hours. What's that? Why is there a half? Why is there a half? What? ln2 over ln2 over 16 hours, which is 16 times 60 times 60 to put into seconds. Is it this? No, what? Huh? Huh? Oh, micrograms. Oh wait, no, that still doesn't matter. Oh my gosh. Oh my, it's literally, you divide by 16, ln2 over 16 equals 0.043 hours to the minus 1. That H just stands for hours. Calculate how long it takes until the mass of that is 8 micrograms. Oh, okay. Well, if the time it takes for a half-life is 16. To get down to 8, how is it? Oh, the half is time for half-life. Oh, that's what it meant. Okay. 8 micrograms. 8's like here, but that's not half of 20. We'll go 40, 20, not 8. 8 over 80 equals 1/10. Oh, if we round it up to, does it say approximate? Calculate. Alright, well, if it's 3 half-lives, how do I do it? Hold the phone. Oh, okay. Okay. So, NT is the value you want to get to, the grams, and naught is the starting value. That's the decay constant, and that's the time you want to find. Okay, easy. Uh, Far out, man. We got to question 25. Let's just leave it at that. 25. Fuck, man. I don't know how people study for that long. Ah. It's honestly just, should I write discursive? Switch it up completely, go to English. Oh, fuck it. Oh, this makes me so sleepy. uh, I'm working late. Oh shit, what is this? some shit on my floor. Okay. What's the date today? The 3rd of the 10th. There you go. Alright. Here we go. Ah, I can't stop yawning. What if I just didn't do this? What if I just didn't Oh yeah. Let's go. Oh shit. What if I just did this? Holy shit, it sounds like ass. I know you guys can't hear it, but like, damn. Oh shit. Oh sh. Wait. Let me back on the. I just found an old one. Please. Play? Where's play? Where's the play button? Oh, here. Oh, shit. Holy shit. Holy shit. Mad nostalgia right there. How do I make a new project? How do I make oh here we go. Let me cook on this one, chat. Hmm. Is it like a virtual? Oh yeah. Wow. And yeah, um, um, this sounds so random that you guys can't hear it, but like, I'm I'm actually just recreating old music. Shit. Oh, this is very boring for you guys, but okay. Oh, I lost it. Oh man. I can't. Oh. Right, here we go. Why can't I delete it? Oh, there we go. Jeez. Okay. This is horrible. How do you make a melody, man? Holy shit, it's shit. Holy shit, it's shit. It's magnifying glass. Yes. Ugh. Ugh. Alright, well, that's that journey. Yeah. Uh, um, I might just go quiet and just knock this out. And yeah, I'll talk at the end. Low? Okay. Um, well, I got nothing. I think let's go round out the stream. I might do some study later. I probably will, but maybe not on stream. Um, yeah. I do the same. I think I need to take a different approach. Like I'll still stream, but I think what I'm studying, I'm just doing a tad lazy. Like I'm just doing the stuff that like writing a discursive. I like writing a discursive, so there's no. You have to do the stuff. If you were to take away one thing from the stream, to study well, you have to do the stuff that you don't like. So I mean, it's good that I'm revising it. Like yes, that was quality study, but however, I've got to do the other stuff too. So that's what it's gonna be next time. So chemistry and English, probably what I'm gonna be doing. Maybe SOR as well. But yeah, and maybe finish off that physics as well. Oh, jeez, it's alright. We'll get it done. Everyone will be fine.